Now notice this illustration shows a panel board being used as service equipment in accordance with the requirements of NEC 408.3C as in car. Now notice once again in the NEC Loop there are a number of sections that we recommend that you review. It's kind of like studying any document, standard, Bible, or whatever you may be reviewing. We just start with 408.3C as in car. That's the first section you would look at. But notice to understand what is being asked for you to do as an electrician or designer is in the NEC Loop. Notice 250.66A through C and table 250.66 deals with grounding. And notice the water pipe system to the right bottom side. It shows a water pipe or copper tubing. 250.104A and 250.52A1 states that that water pipe system, if it's metal, has to have at least 10 feet of it in the earth to be considered an electrode in accordance with 250.52A1. And then notice as it emerges out of the ground, if it's still metal conduit. Then 250.66, the section, refers you to table 250.66 to size the grounding electrode conductor. Now, for example, let's just use 4-aught conductors entering through the service raceway, terminating to the main, which is 225 amps. And based upon the 4-aught conductors, we would go to table 250.66, and that would be a number 2 grounding electrode conductor that would connect to the metal water pipe or the structural steel using the value of number 2 copper selected from table 250.66 based upon the 4-aught. Then notice we would make sure that that grounded conductor routed in and connected to the bus bar that is grounded in accordance with 408.3C to the water pipe. That conductor is a grounded conductor to provide a path for fault current to travel over. Notice that that conductor would be sized from table 250.102C as in car 1, and it too would be number 2 based upon that table, selecting number 2 based upon the 4-aught conductors. But notice 2 tables are used, but the conductors are all the same size. So basically our table 250.102C as in car 1 is an overlay of table 250.66, but the items listed in the table address the grounded conductor, the supply side bonding jumper, and those type of items and conductors that are used to make sure the grounding of the service is proper. And then notice that as long as the phase conductors like the 4-aught terminating that 225 amp main, as long as the KC mil rating does not exceed 1100 KC mil for any one phase, then everything is going to be the same size in that panel board. That main bonding jumper that you see, it would be number 2 also, size from table 250.102C1. Letting the electrician know, or the designer, that table 250.66 is only used to size the grounding electrode conductor when it terminates to structural steel or a water pipe system of metal that is considered an electrode is outlined in 250.52A1. Then notice the driven rod is a supplement to the water pipe in this case, in accordance with 250.53D as in dog 2. It supplements the water pipe in case the water pipe connection is lost in some way. We've supplemented it with that rod so that we still have a connection to earth ground of the panel board. Now next we would pick up 250.104A through C, select the electrodes if they're present in accordance with 250.52A1 through A7. Many times in a facility, you may have a metal water pipe, structural steel, concrete encased electrodes, and if you have a lightning protection system installed, you may have a ground ring encircling the building. Now we would have requirements in 780 as your reference to that standard from 250.60 and 250. I believe it's 106 that we would use. Now, so if all the electrodes, say, in 250.52A1 through A7 are present, they are bonded together to create and provide a grounding electrode system in accordance with 250.50. Now, notice if you have any kind of a lightning protection, we start with 250.60 and also review 250.106, I believe it is. Now, 250.53A through H is usually what electrician uses those sections to install the electrode system. And then finally, we look at 250.54A and B. Now, notice that NEC loop that you see, if you take the time just to review those sections, you will fully understand when a panel board, as you see in the illustration, is used as service equipment, how the grounded bar that you see there, bus bar, has to be bonded to the enclosure. Usually in 250.28, it says it could be a screw, a strap, a conductor, and so forth, is bonded to that enclosure where all your equipment grounds and neutrals would terminate, and then that bar is connected to earth ground, in this case, in the manner as you see. But if you just say had structural steel that was grounded to a concrete encased electrode, then we just ground to the steel and it's done. So this figure 7-2 illustrates a panel board that is being used as service equipment according to the rules of 408.3C and is connected to earth ground. The only other thing that I'll point out is that water pipe system. If 10 feet or more of it is not in the earth, metal, then it is not an electrode. And you'd go to 250.104A and you'd bond it in just like it is an electrode. What is the difference in the sections? If it is an electrode, you have to ground within 5 feet where it enters into the building. If it's not an electrode, you could ground it anywhere that's accessible.